Programming principles they don't teach you in school. An introduction to important principles you should know. Dry, don't repeat yourself. Kiss, keep it simple, stupid. And solid. I probably don't remember all of those. From my experience as a first year undergraduate student and listening to seniors' experience, schools and colleges teach you how to program and also the required math, such as discrete math and calculus. But when you leave university and enter the industry, there are concepts and principles you must know to have an easy transition. We will be discussing about KISS, dry, and solid principles. KISS, keep it simple, stupid. Oftentimes, you will find yourself working together in a team, a group of developers working on different aspects of the project. If you were to switch over and work on someone else's code, would you like to see a messy code without comments or variables? Or would you like to see a nicely documented code that explains that part of the project well? Obviously the latter. Yeah, not overcomplicating code. It's not always easy to write simple code, but yeah, that's what people should lean towards doing. If you are writing a very complex program and say you fall sick, you revisit your project after a week when you recovered, of course you would lose the flow of programming. But would you like to come and see code which you don't understand anymore, or something that you can understand slightly to begin with? Again, the latter. Yeah, that makes sense. That's obviously a very real problem, like jumping into code that you've written and you don't understand it. To be honest though, in my experience, most of the time, I haven't really had this issue. And I'm not saying like I write super clean code, but yeah, I just haven't had that issue a lot. I think it's more of just like being good at reading code as well. Because when you're a beginner, yeah, you might write overcomplicated code, but even if you are writing simple code or reading someone else's simple code, your reading skills just might not be good enough to quickly understand code. I think you just have to get good at reading code in general, and it can take a long time to do that. Now imagine you're working on a project alone and you are working on it every day. You encounter bugs and you need to debug them. How easy would it be to debug the code if your code is more complicated than it has to be? Yep, obviously easier to find bugs when code is more simple. That kind of reinforces keep it simple, stupid. It doesn't just go for code, it goes for infrastructure as well, right? People roast me for using Firebase, but how often do I gotta go in and debug my authentication code? How often do I have to like debug my database? How often do I have to redeploy my database? I never do, because I'm using like software that keeps it simple for me. Any fool can write code that a computer can understand. Good programmers write code that humans can understand. Good quote. At the end of the day, the machine will not care whether you wrote a simple code or complicated code to do a certain task. In contrast, it definitely matters to humans, including you, who would read and try to understand the code. One thing they don't mention is performance. Sometimes people will say, well, my code performs slightly better than this code. When I make a LeetCode video, people are like, hey, my code is actually slightly more efficient than yours, even though like the big O runtime might be the same. It kind of depends on LeetCode interviews, which one would be more preferred. But when it comes to like industry and depending on the software you're writing, like 9 times out of 10, the code that's easier to read is preferable over the code that's like slightly more efficient. They don't mention that, but I think that's also important to note. But how do I keep it simple? Consider a model class, student. This will store 2 items in a map whose key and value are both pairs. The first pair is of 2 strings, the module's name and ID. The second pair is of 2 doubles, marks achieved, and the maximum mark of that module. Okay, so we have a student name, int, and the module marks. So we're mapping a pair to another pair. That's interesting. After making such a design choice, you are now required to record the names of students and the modules in which they scored over 80%. So you have to go through all these modules where they scored more than 80% and find all of them. So to do that, looks like they wrote some code. They're going through the list of students. This is the result. This is the student mapped to the modules. And they're going through every single student. They're filtering for the modules that are greater than 80% and then mapping it to the result. And then just creating it in the form that they want. We know what it's doing. If we didn't know what it was doing, it would be kind of hard to read this. So I think that might be the point that they're trying to make. Coming back even after a few days to a code like this would be disastrous. I kind of agree. I only understood that just because I knew exactly what they were doing. We could kind of see the spots. And there's no comments, of course. Although you can argue this was a fairly easy example, there are ways to make this simpler and introduce some abstractions and variables as possible. Yeah, instead of just having a hard-coded map of modules, we could have an interface for that, and an interface for marks, and to check if one is above a certain percentage. That makes this a bit easier because then when we go student modules mark. We have a method to check if it's above 80. We don't have to hard code like a formula. And then we can get the module name, which was hard to reason about before. So that does make sense. I'm definitely in favor of that code. Next, we have the dry principle. Don't repeat yourself, except sometimes it is okay, at least in my opinion. If you find that you are performing the same code over and over again, create a function and reuse it, of course. In my university assignment, I was working on a set of objects, and most, if not all, functions defined required me to search and fetch a particular object from the set and operate on it. Okay, sounds like an easy way to move some code into a function. So here we have a spreadsheet which has a bunch of cells. Given a cell location, we want to get the value of that cell. So it looks like we have to filter these cells for the location. And it looks like that is the duplicate code. This block here, searching for that cell, is duplicated in every single one of these functions. It's not like a ton of code, but I think in this case, given that it's repeated 3 times, it makes sense to put it in a helper function. If it was just 2 times, though, at that point, I think it's debatable. There's nothing wrong with putting it in a function at that point, but I don't think it really matters that much. Because at least in my experience, in big code bases, even if there is a helper function like this, you might not know about it. You might not even find it because it might be hidden somewhere. At that point, you might end up rewriting the code anyway, but I think that's a minor problem. That's a lot of code above, but while I was typing this code, I found myself copy and pasting the same block of code multiple times. Hence, I abstracted them into functions that I reuse everywhere. That's a good rule of thumb when you're copy and pasting code, to move it into some kind of shared code. So now we have a lot less code because we took that code and moved it into this helper function. Pretty obvious example, I think. If I realize there's a bug in my code, I do not have to change the code at n different places. Changing it once inside the function is enough to fix the bug everywhere. Yeah, that's a really good example of the dry principle. Duplicated code means you have to update that code in multiple places. Even if there's not a bug, if you just want to change the behavior of it. And of course, sometimes you might change it in one spot, but not the other spot. So then you get like out of sync code. Just some basics on the dry principle. And finally, we have solid. I don't know if you guys can name all of these. Okay, so obviously we have single responsibility principle. I think the O is open closed principle. L is somebody's name, but I think it is something like substitution principle. I think objects of like the same subclass or superclass should be able to be substituted for each other. Like the behavior shouldn't break. I believe is interface segregation principle, so that you don't want like 2 big interfaces. And D, I don't remember what it stands for, but I'm pretty sure it's related to dependency injection. Let's learn about these now. Solid is 5 principles. 1 is single responsibility. These mainly center around object-oriented programming, so a class should have one and only one reason to change because it should mainly be responsible for one thing. Possibly the easiest principle to understand. Every class function that you define must perform only one task. Consider that you are building a networking application. Here we have a repository. We are given a database, a remote database and a local database. Fetch remote data, and we can get that data. Okay, the above code is in violation of the single responsibility principle. The function does not only fetch remote data, but it is also responsible for storing the data locally. This should be extracted out to a different class. Depending on the context, I would think that sometimes this is fine, but it seems like this is more of a single function anyway. This doesn't even need to be in a class, but let's continue. The solution here is this function now fetches the remote data and then sends it so that it can be stored in the caching service. And it looks like the caching service is now a dependency for the repository. Okay, so the code it's still being saved from within this class, but it's being saved by another class. Okay, that makes sense. I think that's completely fine. Notice how my caching service is responsible only to save the incoming payload into the local database, while the repository is responsible only for fetching the data for the sending model above. It is a good practice to do this because of something called separation of concerns, which improves debugging and testability. Yeah, I think this makes a lot of sense, like on the back end where you kind of have like the database layer, the business logic layer, and like the API layer, and things are kind of segmented in that way. I think when it comes to front-end development, separation of concerns has kind of blurred the lines lately with like React and everything. Open closed principle. This one I know pretty well. Software entities should be open for extension, but closed for modification. You might be wondering, how is a class going to be closed for modification? You can't change it, but you can somehow extend it. And that's how object-oriented programming works. There's a lot of ways to do that, and people aren't always fans of all of them. This principle basically means that do not write software code that in future changes breaks the client-side code. Basically, you want to minimize changes because many things could be dependent on certain classes. You can break things. And yeah, dependencies are like the big reason for that. Consider you are building a web dev API in Kotlin. You have designed the paragraph tag, the anchor tag, and the image tag. In your code, you were asked to compare the heights of two elements. Okay, so it looks like each of these has a height. And in the client code, it looks like we have methods for each of these classes that can check, is this taller than another element? And we have that for a few of these. That was a lot of work. Now you have new requirements asking you to include a heading tag as well. You would have to add 6 more functions in the client side. Not only is this tedious, you are also modifying the client side code to fit your program's needs. Instead, declare an interface page tag. So now we have an interface, and all of these will implement that interface, it seems. So even though this is like the paragraph tag, this is the anchor tag, they will all have like the same subtype, which is the page tag. They will share that. So this is what I was talking about when I was talking about like the substitution principle. Now, any of these tags can be passed into this because it's the page tag. We just have one single method now, which exists on the page tag, not on any of these, which checks is a different element taller than the current element that we're calling this method from. So a pretty elegant solution. This is a way of adding a behavior to an object without actually modifying the objects. Well, I guess this is kind of a blurry way because we technically do have to make these implement that interface. But I guess now at this point, we have closed the client code for modification. In order to extend your functionality, it is open to create a new class and implement page tag, and everything will work perfectly. Cool. Next, we have the substitution principle, the one I was kind of talking about. If S is a subtype of T, then any properties provable by T must also be provable by S. So that's, I guess, the math definition, but it's pretty simple. If you have a penguin class here, which inherits from the bird class, and the bird class has these methods, fly and eat, you should be able to call those methods on the bird as well. Technically, this has the fly method, but it does throw an exception because a penguin cannot fly. So it technically does break the substitution principle because throwing an exception generally like breaks the flow of code. It doesn't continue at that point. You have to handle it in some specific way, and you wouldn't expect that. If a class is going to inherit from another one, it should be able to implement all of the methods. You should be able to call all of them. So this is really one of the problems with inheritance. This is why people aren't fans of inheritance. Interfaces are usually a better way of going about it. Let's continue. Notice how the bird class above does not throw any exception, while penguin does. You cannot replace penguin with bird in your client code without breaking or modifying it. This violates the substitution principle. Yeah, we don't want to have like an extra if statement just for penguins. We don't even want to have to subtype them. Given a bird, we don't want to have to check, is it a penguin? And then write some additional logic. That's annoying. So penguin extending the bird breaks the client-side code, thereby violating the open-closed principle. Okay, yeah, it violates both principles. A way to fix this is to change your design implementation. So here we have a flightless bird, and then we have a bird. Now, penguin, instead of inheriting from a bird, is going to inherit from a flightless bird. So now we just kind of made the inheritance hierarchy bigger. It probably solves this problem, but this is sort of an overcomplicated way of probably like the main reason for inheritance in this case is sharing code for polymorphism and stuff. It might have been easier. We'll just continue. This code above explains if a flightless bird can eat, then all subclasses of flightless bird can also eat. Similarly, if bird can fly, then all subclasses of bird must also fly. Interface segregation. Interfaces should not force their clients to depend on methods it does not use. So this is the problem where an interface just becomes too fat. It's similar to the single responsibility principle, in my opinion. Consider that you are building a car, an airplane, and a bike. Since they are all vehicles, you are implementing the vehicle interface. So here we have a FAT interface, a vehicle interface. It has a bunch of stuff: turn on, off, drive, fly, pedal. So the problem here, without even looking at the rest of this code, you can probably guess, why do we have all three? Because usually with an interface, if I'm implementing this interface with my class, I have to override all of these. Generally, that's what you want to do. But these don't need to be grouped under the same interface because, as we can tell, vehicle is only going to need to drive, not these two. Airplane just needs to fly, and a bike just needs to pedal. The main reason you might have created an interface like this is because you want these to all have the same subtype, vehicle. And there is some shared code, well, shared methods, like they all can turn on, off, but actually using that vehicle is going to be different. So these should have been put probably in their own interfaces. Yuck. See how the classes are forced to implement the methods it doesn't need to. I also cannot declare the classes as abstract. By interface segregation principle, we should instead have this design. So here we have pretty much that. System is runnable. It's not even called a vehicle at this point. And we have drivable, flyable, and pedalable. And so now each vehicle type just gets the interface that it actually needs. Now this looks a lot cleaner and it's easier to reference different capabilities by their interfaces. Lastly, dependency inversion principle. So I think I'm right with dependency injection because modules should not depend on lower level modules. Both should depend on abstractions. Abstractions should not depend on details. Details should depend upon abstractions. What does this mean? High-level modules are those modules that the business or UI sees. Lower-level modules are those which handle intricacies of the application. Recall from single responsibility principle. Here we had a repository, and notice that the dependencies are supplied to it, the API and the cache. It doesn't have to construct these from inside the method. It's not responsible for doing that. It's just given to it. So that's like one main part of the dependency inversion principle. When they say this word abstractions, part of what that means is that we might have multiple remote database types. Like this might be the super type, and there are different databases that like might inherit from this, and those can be swapped in and out. Like you could supply a different database if you wanted to at runtime to this class. I think maybe they will do a better job of explaining. Let's continue. It looks all right and it will work perfectly. However, in the future, if I decide to change my local database from Postgres to SQL, or if I decide to alter my caching mechanism completely, I would have to change entire implementation details and client-side code as well. High-level modules depend on low-level concrete modules. This is not right. Instead, you must abstract the functionality into an interface and have concrete implementations extend it. So this is a little bit controversial because here they pretty much did what I was talking about. Now we'll have an interface for every local DB and an interface for every caching service. And we might have like specific, and those are the ones that we provide now to this repository. And now the caching service will implement that, and we'll have a different caching service to implement that. We'll have a couple different local DBs. This repository now is extensible. It does not depend on a concrete class. It does not depend on Postgres or MongoDB. It just depends on any remote DB. So now we've added flexibility to this class. Depending on what we pass in, the behavior of the class will change. That's good, but it's almost premature optimization, isn't it? Because now this is a lot more code. This is a lot more interfaces and classes to keep track of. And the way they reasoned about adding this was just a hypothetical. What if we had multiple databases? Well, if you don't, you can always refactor the code to add these interfaces later when you actually need to. At least in my opinion, when I'm like going through code, usually a Java object-oriented code base, and everything has an interface. Everything, like in this case, if we just had one implementation of remote DB, but we have to add an interface around it just to make this extensible, it gets kind of annoying, it gets tedious, and it doesn't feel necessary. But technically this is extensible code. Doesn't mean it's the perfect code to write depending on the circumstance. You can easily change among different implementations for your repo in your entire application by changing one word. This gives me the chills every time I listen to it. Okay. This was a pretty good article. It was pretty beginner oriented. which I think is fine. Let me know though if you actually learned any of this in college, because I feel like most of this I personally did, but maybe you didn't. Let me know.